Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes quantitative data, which includes both discrete data and continuous data. Let's get started. Let's take a look at the first main type of data, quantitative data. Quantitative data consists of numbers representing counts or measurements. Now, most of the time when you see data represented as a number, it will be quantitative data. But that's not always the case, as we'll see a little later. But usually when you see numbers in your data, they'll be quantitative data because those numbers will represent counts or measurements. This is why quantitative data is also called numerical data, because the only way you're going to express counts or measurements is with a number. Now, here are some examples of quantitative data. We have the weights of supermodels, the ages of respondents, the number of eggs in a carton, the distance between two cities, and the quantity of coins in a jar. These are all examples of quantitative data. Now, quantitative data, unlike ice cream, thank goodness, comes in two flavors. The first flavor is discrete data, and the second flavor is continuous data. I mean, hey, I'm a total fan of vanilla and chocolate, but I'm so glad there's so many more flavors of ice cream than just two. When it comes to quantitative data, however, you have only these two flavors, discrete and continuous. Let's take a look at each one of them in more detail. First, let's look at discrete data. You have discrete data when the only possible values are whole numbers. So you're counting whatever as whole units. That's discrete data. If you can report part units as well as whole units, then you don't have discrete data. If we take a look at the examples of quantitative data we just saw, we can identify which of them are discrete data by applying a definition in each instance. First, let's look at the weights of supermodels. Well, the weight of anything is going to be described not just with a whole number, but with a part of a whole as well. It's very, very uncommon for someone to be exactly a whole number of units of weight, whether you're talking about pounds, kilograms, or what have you. So, the weights of supermodels would not be an example of discrete data. Note that many people report weight as a whole number, but it's not about what people do report, but rather about what they can report. Weight can be reported legitimately with part units as well as whole units, therefore it is not discrete data. The ages of respondents, likewise, would not be an example of discrete data. Typically, when you ask them how young they are, people respond with a whole number of years, but that's not how old they really are. Their age really has a certain number of months, weeks, and days, as well as years. So, people who say they are 25 years young because they had their 25th birthday 55 days ago are really 25 years, 1 month, 3 weeks, and 4 days, depending on the month, young. What I'm getting at here is that you've got partial years as well as whole years. Therefore, the ages of respondents would not be an example of discrete data. The number of eggs in a carton, well, that is an example of discrete data because you don't count partial eggs, only whole ones. Whole numbers are the only possible values here, so this is an example of discrete data. The distance between two cities is the same as age. You're going to give part units as well as whole units. So that's not going to be something that we call discrete data. However, the quantity of coins in a jar, yeah, we're not counting partial coins. We count only whole coins, so therefore the quantity of coins in the jar is an example of discrete data. You may have guessed that we have continuous data when we do when we do count part units as well as whole units. And if so, you'd be right. Continuous data could be reported as a whole number, but it doesn't have to be. That's what distinguishes it from discrete data, which can be reported only as whole numbers. That's why this is called continuous data. The possible values you have come from a continuous scale covering a range of values. Let's look at the examples we just considered of quantitative data and see which of these are continuous data. The weights of supermodels. Well, now this is an example of continuous data because, as we just discussed, the weight of anything is going to be a part and a whole. So yeah, that's going to be continuous data. The ages of respondents, likewise, is going to be an example of continuous data because you have a certain number of years, but then there's a partial number of years. Number of eggs in the carton. Well, that's discrete data, as we saw earlier. You're counting only whole numbers of eggs. The distance between two cities, however, that is an example of continuous data because you're going to use part units as well as whole units to describe the measured distance. The quantity of coins in the jar, as we saw earlier, is an example of discrete data because you're counting only whole coins, not parts of coins. And that brings us to the end of this mini lecture. I hope you found it helpful. If you'd like some practice with this topic, check out the next mini lecture. And as always, you can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching, and I'll see you in the next video.